Hey everyone, welcome to another exciting SIRIN Labs Facebook Live. I am joined here this week by a very exciting guest, our Chief Security Officer,
Hello.
Oren Ben.
Hi.
Some of you may have remembered him from his last Facebook Live, but in case we have some new viewers or some new fans, could you just give a little introduction?
Yeah, of course. So, hi everyone, welcome. I'm the Chief Security Officer and the product owner of the wallet in the SIRIN Labs. I'm in SIRIN Labs for the last 3 years. Before that, vast experience in product ownership. I was a VP product of a Homeland Security company. And before that, I served most of my life in the Army, Lieutenant Colonel in the IDF. And here I am in SIRIN.
Fantastic. So just to sort of jump right into some of the questions we received from the community, there still seems to be some confusion over what SIRIN OS is as opposed to like basic Android. So could you maybe explain how SIRIN OS differs and how sort of it's layered onto the Android operating system?
Okay, so the SIRIN OS is based on the AOSP, an Android open source project. So it's a plain Android version with a lot of modification that we did and we are doing for SIRIN as we did in Solarin, in fini as we did in Solarin. And of course, we are going to implement the embedded cold storage wallet with a lot of cybersecurity measures. And I think the most significant thing to do to understand that we are not relying on an on-top traditional application of cybersecurity, but we are taking all of the operating system and building the cybersecurity solutions from the kernel level, from the low level to the application level, unlike other solutions that we can find at Google Play, for example, some kind of a antivirus or anti-malware solution, which is an on-top application solution. It's not part of the Android itself.
Okay.
So the main differentiator is, of course, that we are the owner of the operating system, and we are, of course, certified by Google, and we are integrating all of the solutions of the operating system from the top, from the bottom layer to the application layer of the operating system itself.
Awesome, thanks. So part of that, those security features that we're going to be putting into the SIRIN OS is the behavioral intrusion prevention system.
Yeah.
And while that sounds very fancy, can you help myself and some of the community members to really understand what that is and what that does?
Okay. So the intrusion prevention system, the IPS, is an integrated solution, as I mentioned, from the lower level to the application level. Its main objective is to, first of all, detect all kinds of attack surfaces. It could be both in the network attacks as well as host-based attacks, or what its common name is malware attacks. So the first objective of this solution is to detect all kinds of attack verticals through the operating system. And of course, the other objective is to block it. So this is the prevention. The IPS includes a lot of cybersecurity policies that can detect a lot of attack verticals and can cope with them with different kind of mitigation measures, such as blocking the installation or closing the Wi-Fi if, for example, a man in the middle is being discovered while using a public Wi-Fi or unsafe Wi-Fi. So the first part is the detection, the other part...
And what is a man-in-the-middle attack?
For example, if someone is going with his smartphone to a public coffee shop and is using the public Wi-Fi that is being offered, for example, Starbucks, I, as an attacker, can build an access point, which is similar to the access point, to the legit access point of any coffee shop. I can even give him the legit name. You think you are connecting your device to a regular access point, to the normal one, to the expected one, but in practical, you're connecting your device to the attacker device, the attacker access point. And from now on, all of your traffic are going through the attacker. That means that it can record, get access to emails, content, to SMSs, not also if it's an access point, but you can reach your Telegram or WhatsApp, etc., pictures, everything that I'm delivering through this access point.
Right. So the IPS is able to register or recognize that this has happened.
Yeah. The main, as I mentioned, its objective is to detect it and to prevent it. And we need to do it even if the user is unaware of the attacks. For example, I can go to the Starbucks and put my device in here. It's now connected to the Wi-Fi and not looking at the screen. But in this case, some attacker can execute this attack. So I need, first of all, to execute the countermeasures and, of course, notify the end users whether this kind of attack was detected and which countermeasure we're operating.
Got it. So I just wanted to let everybody know, we see that there are some comments coming in. There seems to be a technical glitch similar to what we had last week, where we're not able to see them in real time. But we will come back and answer all of your questions, or as many of them as we can, after the broadcast. A couple more people had sent in questions beforehand. So just one thing that I know a couple of people were curious about with regards to again, with the SIRIN OS, if there was really a need for it, because a lot of people are using antivirus software and anti-malware software on their phones already. So is the SIRIN OS really necessary in terms of gaining the security needed on your phone?
Well, of course, if a user is using an antivirus, most of them are not using it, sadly. But even if I'm using a commercial antivirus, its sensors are spread only on the upper layer of the Android operating system. So a lot of events that are hidden from the upper layer are not detected by this antivirus. And because of that, we need to have a deep integration of anti-malware of this IPS in the operating system in order to provide our customers the best cyber protection. Because this device is not just a regular smartphone. This device is the first smartphone in the world that will have your crypto with you, and we need to protect it. And of course, the issue is not just the IPS. The embedded cold storage wallet itself is not like an application, on the wallet application, a warm application that you are downloading from Google Play or from App Store. It's something that is embedded into the operating system in the lower level. So we need to have a proprietary operating system based on Google and certified by Google that enables us to deploy this kind of a solution for embedded cold storage wallet. And I cannot do it. I cannot have an embedded cold storage wallet, hardware-based, on a regular Android, because otherwise it will be like a regular APK for a warm wallet. And I need a deep integration into the operating system for an embedded cold storage wallet solution.
Right, and that sort of leads into what the next question was, which was, what's really the difference between the wallet on the Fini and any other wallet application that anyone can download through, like the Google Play Store or anything like that?
Okay, so first of all, of course, the downloadable wallet applications are not cold wallet. They are software-based wallet, and I think the most two significant differentiator is, first of all, you cannot compare, you cannot validate the destination address, you cannot validate the crypto type, and you cannot validate the amount. You can practically see the things that you want to see, but the hacker can display one thing on the main screen of the application, and in practical is sending to another address or another amount just put away the decimal 2 points and you have a different amount.
Yes.
And you can switch the maybe other things. So first of all, you cannot validate the critical data for a crypto transaction, which is being made now in cold storage wallet like Trezor or like Ledger. But the other differentiator, of course, that we want it in one form factor. So we have an embedded cold storage wallet within the device itself. And of course, the most important thing is to hide the private key or the mnemonic for the more professional guys in the audience. So we need to hide the private key and the mnemonic inside a very, very protected place, which is a dedicated zone in the device itself, which is not the regular hardware of the device, but another zone that is protecting the mnemonic and the private seed of the end user. And of course, we are going to expose it only if I need to sign a transaction, if I want to execute a photo update or to execute a wipe. So the other change from a regular software-based wallet is the location of the private key and how I protect this private key from a hacker that can steal it, clone it, and do whatever you like.
Got it. And one thing that I think a couple of people are also confused on is how a wallet could be a cold storage wallet, because again, a cold storage wallet is something which is completely disconnected from the internet. How that could be part of a smartphone.
Okay, so very like other cold storage wallet today that you are connected it into your Mac or to your laptop PC through a USB cable. In our case, we are talking about one form factor. So we have a hardware section, hardware components of the embedded cold storage wallet, which are connected in some kind of a secured measure, of course, to a wallet application. And the interaction between the wallet application and the embedded cold storage wallet, the hardware component are done all the time once, but unlike other wallets, I will need to open the cold storage wallet and authenticate only if I need to sign a transaction. So all the time that I want to operate the application itself, to see my balance, to see my portfolio, etc., I can use it without exposing the private key, without authenticating into the hardware wallet. And only if I want to sign a transaction, to make a request for receiving a crypto, etc., or to add accounts, add more crypto types, then I need to open the hardware wallet, authenticate with a password, or if I'm an advanced user, with a passphrase also, and then use the hardware wallet. So a hardware wallet and the wallet application are two separate parts. They are not interacting unless I'm giving them the specific command to do it. And then, of course, the Android don't know nothing about what's happening in the hardware wallet and vice versa.
Got it. So if that's the case, then why would the Fini's cold storage wallet be any more secure than any other external cold storage wallet that you could purchase?
Okay. So first of all, regardless the security level, we need to understand that this is the first time in the world one form factor, not two form factors.
Right. So you don't have to carry on multiple devices, which is nice in and of itself.
This is first of all, and the second, we are talking about the most used computer in the world, which is the smartphone, not the PC, or not carrying your PC all the time. And we are, as we mentioned in the beginning of this conversation, we are talking about a device which is protected by an IPS, behavior-based IPS. And nevertheless, even if I were doing this IPS, our working assumption that the device could be rooted. So all of the security measures, the countermeasures of the embedded cold storage wallet, the interaction between the wallet itself and the wallet application is based on, as I mentioned, working assumption that the device could be rooted, and the security measures enable us to have a secure transaction, secure protection of the private key, etc. So this is one form factor, a very strong IPS, and nevertheless a protection even if in cases of a root to device that could be, of course, tempered and compromised by an attacker.
Mm-hmm. So even if someone were to get a hold of your device and root your device without your knowledge, your private key would still remain secured.
Yes, and of course the IPS itself will help the end user to understand that this device is rooted, and maybe should stop using the device and the cold storage wallet and go to some kind of a mitigation measure. So even if we cannot block the attack on the regular device, still the encrypted the private key is protected, mm-hmm. and the user is being warned not to use the device anymore till some kind of a mitigation.
Got it. And the last question is one that we get all the time. What happens if you lose your phone? Okay. Do you just lose all of your money?
Okay, so I assure that everyone that use a lot of time the wallet understand that in the wallet there are no crypto at all. The wallet is some kind of a way to protect and store your private key. The private key, this wallet is just any other BIP39 wallet. So you have your mnemonic with you, you have your passphrase with you. So even if the device itself is being stolen or lost, etc., so you can restore your mnemonic into another fini device. Mm-hmm. You even can restore other BIP39 wallets into this device. So the main issue is how to show that you are the owner of this private key through the mnemonic of BIP39, and then of course all of your crypto assets are safe on the blockchain and not on the device itself. So you need, of course, to keep your mnemonic. Of course, the mnemonic, of course, it's
don't lose that.
Don't lose the mnemonic, the seed, if in other terms. Mm-hmm. So keep your 24 words and then restore it to the new fini that you're going to get if you're going to be some kinds of not reach your original device.
Wonderful. Well, Oren, thanks so much for coming on and answering our questions and taking some time out of your day to talk to the community. Join us next week for another exciting Facebook Live. We'll see you then.
Thank you.